right, so last section we're going to take a look at is 10.1, and that's on solving systems of equations. So just a reminder, when you're solving for a system, that means you're not solving for a single variable, you're solving for a minimum of 2 or more. The kinds of systems that we're going to focus on are going to be 2 and 3 variable. You can do more. You can do as many variables as you want. The methods that you use as the number of variables increase, they change. Substitution and elimination, those are good for 2 variable systems, 3 variable. But if you start getting into 4 or 5 variable, we want to transition to using what's called a matrix. Not something that we're going to look at the way we do it, but it is a more efficient method, a more organized method when you start having a lot of variables. All right, so the first problem, we don't want to solve it yet. Let's just set up the equation. And they're telling us that we have a rectangle. They want us to find the length and the width, and they give us a couple things. The perimeter of the rectangle is 100, and the area is 300. Sarah, how many equations am I going to need to write down to represent what they've given me in that example? Yeah, we're going to need 2. What's one equation going to be for? Say it again? It'll have length in it, but I'm thinking one of the equations needs to contain a certain piece of information they gave us. Kylie, what's an important piece of information that we're going to need? And this is going to control the formula we have to figure out.
The perimeter.
What is it?
The perimeter.
Yeah, let's start with perimeter. So one of the equations is going to be for perimeter. So you need to figure out the formula for perimeter of a rectangle. Okay, so let's start with that. So if it's a shape that's not familiar to you, like I'm not going to ask you like an area of a shape that wouldn't be something common, like an octagon. Right? You can probably figure out the area of an octagon if you make it into triangles and break it up. But rectangle, you should know the formula for the perimeter of the area. Hadley, what's the formula for perimeter of a rectangle?
Side plus side plus side plus side.
And can you? So that would be kind of in general for any 4-sided shape. Can you make it specific to a rectangle?
Would be like 2x or 2x plus 2y kind of.
And what do the x and the y represent?
One's the left, one's the right.
Okay, so we could do it that way. So let's do x and y. So specifically for a rectangle, the perimeter is 2 of the lengths plus 2 of the widths. So 2x plus 2y. And based on the information in the problem, Eileen, what is 2x plus 2y going to equal? 100. So there's my first equation. If that's the only information that I had, there's an infinite number of answers to that problem. Okay? But they give me more information. They tell me the area has to be 300, so that's going to narrow it down. Okay? So perimeter, we got that equation. Aiden, what's my next equation going to be for?
X times y is 300.
And what is?
Area.
Yeah, that's for area. So next equation is going to be using the area. So now think of the formula for area of a rectangle. Length times width. So length times width. And what did you say that's going to equal? 300. Okay, so for this, that's all they wanted us to do. We are going to come back and solve that problem in a little bit. But I want to talk about the 2 methods you could use to do it. Well, at least the 2 methods we're going to go over. Any questions on those 2 equations? All right. When you are solving a system, does anybody remember, I think I already said it, will anyone remember one of the methods you can use to solve a system of equations? Yeah.
Substitution.
Yep, we're going to do that one first. So substitution, that'd be a good one for this. And there's one other method you can use that we're going to talk about. You want to know the other method? Yep.
Elimination.
Elimination. So those are the two that we're going to look at. Graphing is always an option, but this section doesn't focus on graphing. It focuses on algebra. Okay. All right, let's start by talking about substitution. So the idea with substitution is you're going to pick one of the equations that you're either given or that you had to make, and you're going to solve that equation for a variable. Okay. At that step, you're not going to know your answer yet. Okay. You're only going to be rearranging one of the equations. That's the first step. Now, once you rearrange it, then you're going to take what you do in that step and you're going to plug it into the other equation that you haven't used yet. So let's call it equation 1 and 2. You're going to rearrange equation 1 to get a letter by itself, and then you're going to plug that in for the letter in equation 2. Once you do that and you simplify, you should now know one of your answers. So at the end of step 2, you have an answer. But since we're solving for two variables, you're going to take that answer that you got in step 2. You're going to plug it back in. Doesn't matter which equation you pick. We'll try to pick the simplest one. And when you plug it back in, that's going to give you your other answer. So even though we are doing things algebraically, I am going to reference a couple visual concepts, things that might be important for the test. But the main focus is on using algebra to solve these. All right, so let's take a look at, that's the same problem we had. I might have written 2x plus 2y instead of 2y plus 2x. That's the same thing. Okay, so at your first step, you have 4 choices. You have 2 equations to pick from. Each equation has 2 letters. So we need to pick an equation and then pick a letter in that equation. So which equation here do you think would be easier to solve for a letter? The top equation or the bottom? Yep.
The top one.
The top one. Okay, how come?
Because all I have to do is just divide two from each side and subtract one of the letters.
Yeah, we could do it that way. So we could divide everything by 2 in the top equation. So that gives you y plus x equals 50. And then you said to solve for what letter from there?
Pretty sure you can solve for anyone.
Yep.
So let's go for x.
Okay, so let's solve for x. And if you solve for x, what will be in that box? Yeah.
50 minus y.
50 minus y. So it took us 2 steps to get a letter by itself in that equation. They weren't hard steps. If we had picked the bottom equation, we could have gotten a letter by itself in 1 step. So the bottom one might have been a little bit quicker, but the top one still wasn't too bad. So we picked the top equation and we solved it for x. Now, what am I going to do with this 50 minus y? Yep.
Substitute it into the bottom equation for x.
Yep. Substitute this into the bottom equation for x. Okay. When you substitute it in, make sure you use parentheses because you may end up with a distributive property. Okay. So you're going to have 50 minus y. That's what I filled in right there for x, times y equals 300. All right? And Elise, what do I have to do with this y that's on the outside of the parentheses?
Distribute.
Yep. And can you tell me what we get when we distribute it?
50y minus y squared.
Yep. I'm just going to put it in that kind of standard order from highest to lowest exponent. So negative y squared, and then plus 50y. But 50y minus y squared is the same thing. And that equals 300. And looking at that equation, especially because of the highest exponent, what do we call that type of equation? Yeah.
Quadratic.
It's a quadratic, yep. And Hunter, when we solve a quadratic, what do we always want to get it equal to?
0.
Want to get it equal to 0. Yep. So what I'm going to do is, I like the squared term to also be positive. I'm going to put everything on the right. So we're going to have 0 equals, add the y squared, subtract the 50y, and plus 300. Okay, Reese, what's one way that we can solve a quadratic? Yeah, we could try to factor it. I don't think the numbers are going to work out nice here to be able to do that easily. So what's another method you could use if factoring doesn't work? That's right. Anyone help them out? What's another method you can use to solve this kind of problem? Yeah. You can use quadratic formula. Yep. And Alex, can you remind us what is the quadratic formula?
It's ax cubed plus bx squared plus c. Sorry, not dx plus bx squared.
So that's how you write a quadratic equation in general. Like if you want to write, like, it's kind of like saying y equals mx plus b. It's just kind of filling in letters for the coefficients and the constant. But we're looking for the formula that would solve a quadratic. So it's a little bit longer than that. Yep.
Negative b plus or minus the square root of 2 b squared and minus 4ac subtracted. No, not subtracted. Divided by 2a.
Good. Now, what you were referencing when you said ax squared plus bx plus c, that's the letters we use in the formula, but that's how you apply them. So a is going to be coefficient of the squared term, b is the coefficient of the linear term, and c is the constant. Okay. So Sarah, when I fill in all my numbers for a, b, and c, can you tell me what my formula will look like? 50 plus or minus. And 50 squared, yep, I'm going to do that out. So 50 times 50. Yep, 4 times 1 times 300. Looks good. Over 2 times 1, which in this case would just be 2. Okay. So let's do all that out. So we get 50 plus or minus the square root of Kylie, what's going to be under my square root there? 1300. And now let's find our answers. Now we're solving a system and we're using the quadratic formula. That means for the variable we are solving for right now, we're going to get 2 answers. So I'm going to call them y1 and y2. Now we are finding the length of a side in a rectangle. So if we get a length that's negative, we can ignore that answer. If both lengths come out positive, we need to write them both down. So let's type this in. So we've got 50 plus the square root of 1,300 divided by 2. And that gives me 43.028. Okay, now I'll do the same thing again, except I'm going to do minus instead of plus. So 50 minus the square root of 1,300 divided by 2. And they both come out positive. I didn't get a negative. So I need to write them both down. 6.972. Okay, so I've got y1 and y2. What do I need to find now? Yeah. Yeah, I need x. And x is going to have two answers. x1 and x2. Okay, to find x, we've got a formula right here. All you have to do is take 50 and subtract y, and that'll give you x. So let's take 50 and subtract 43.028. We get 6.972. All right. And now, if we take 50 and subtract 6.972, we get 43.028. So those are our two answers. X1, well, Y1 and X1, that's one pair. Y2 and X2, that's another pair. And they're sides of a rectangle. What's the difference between the rectangle using the top two numbers and then the rectangle with the bottom two numbers? Yeah.
The top one would stretch out vertically and the bottom one would stretch out horizontally.
Yeah, it's just a direction of which way it's kind of facing. So if one of your answers looks like this, then the other one would look like that. There's your two answers. All right. So we do get two different answers, but now let's think about visually why we get two different answers. We had a system of equations. If you draw something like this, y squared minus 50y plus 300, what kind of shape is that? Hadley, what kind of shape would that be?
A rectangle?
So like if you put something like this in on your y equals, and we'd use the letter x instead of y, it would draw a rectangle on the screen?
No.
No. So what shape would that make if you drew it on your calculator?
I'm not sure.
How about Alex? Can you tell us what shape it would make? Parabola. It's a quadratic equation, and the shape of a quadratic is a parabola, specifically with a positive value. It means it's opening up. So something like this. It's a parabola. Now, we have a quadratic on one side, and we have a constant on the other. What kind of shape is a constant if you type in like y equals a number? What does that look like on the calculator? Yep. That would be a line. Specifically, this is a line at y equals 0. So imagine here's your parabola, and if these were your axes, I'm just making that up, you're drawing in a line at y equals 0, right at the x-axis. So you've got a line on one side, you've got a parabola on the other. That means you're going to get two different points of intersection. That's not exactly what this one looks like, but that's the idea. That's why you get an x and a y value here, and another x and a y value here. 2 x's, 2 y's. And those are your answers. So any question on that? So visually, the answer is intersection points. Not what we're going to focus on today, but if you were graphing, that's what you'd be looking for. All right, let's try this one. Eileen, if I drew this top equation on the calculator, what shape would it be? It would be a line. Why wouldn't it be a parabola?
Because nothing's square.
Nothing's square, yeah. It's just all variables to the first power, no fractions with variables in the bottom. So yeah, that would be a line. How about that bottom one? Aiden, if you drew that, what would that one be?
Also linear.
Linear, yeah. They're both linear. So when you draw two things that are linear, if they're not the same line, and they're not parallel, how many times can they cross each other? Yeah, just once. Okay. There are special cases, like if they were parallel or the same line. But if these are both lines, and they're not the same line, and they're not parallel, they can only cross each other in one spot. So we're going to be looking for a single x value and y value. All right, so let's try it with substitution. Elise, which equation here would be easier to isolate a variable?
Oh, the first one.
Yeah, I would say the first one. Anytime you find a coefficient of 1, that's the one you kind of want to go with. And which variable would be easiest to get by itself in the first one?
Y.
Yep, so let's get y by itself. Reese, can you tell me what I would get when I rearrange that top equation to get y alone?
5 minus 2x.
Yep, 5 minus 2x. And Alex, what am I going to do with the 5 minus 2x now?
Plug it into the bottom equation.
Yep, plug it in, and where are you going to plug it in?
To y.
To y. Yep. Right there. Okay, remember, when you fill that in, you could have distributive properties, so make sure you use parentheses. Okay, so now you've got 3x plus 2, and then we're going to fill in what we got for y, 5 minus 2x, equals 2. And Sarah, what do I have to do with that now? Yep, and can you tell me what I get when I distribute the 2? Yep, plus 10 minus 4x. Okay, that's good. Okay, Kylie, my next step.
Add like terms.
Yeah, we can combine those like terms. What do you get when on the left side when you combine your like terms?
Negative x plus 10.
Okay, so 3x minus 4x gives us negative x. Hadley, my next step.
Subtract 10 from both sides.
Subtract 10. So 2 minus 10. It's going to give me negative 8, which means x equals 8. There we go. So there's our x value. And now, Eileen, what do I still have to find?
Y.
Yep. And how would I get the y value?
You plug it into the other equation.
And which equation should we plug back into to make finding y as easy as possible?
First one.
So plug y back in the thing that I just underlined. I mean, plug x back in. You could plug it in there. Where else could we plug it in? It would be even easier. It would be one less step than plugging it back in where I underlined. Yep.
Y equals 5x to x.
Yeah, I would fill it back in here. Then the y is already by itself. You don't have to do that part again. And we get y directly. So y equals 5 minus 16. So 5 minus 16, that's negative 11. You can write that as a coordinate if you want. You could do 8 comma negative 11. But I think it's going to be set up on the test where you have a box for x and then a box for y, and you put a separate number in each box. Okay. Any questions on that? So we said these were lines. If I drew both of them on the calculator, what would be happening at the point 8, negative 11? Yes. Right, it's where the lines intersect. Okay, not the focus for today, but I would know that. Okay, elimination. So elimination is a method that works well when you have two equations and they're exactly the same format. Like x is in a column, y is in a column, constants in a column. Elimination would not have been as good for this one because you didn't have a number with just a y and a number with just an x in the bottom equation. Okay, so you really got to do substitution on that one. But this one we could have done elimination. We had numbers with x, numbers with y, and then just constants. So the goal with elimination is to add equations together, okay? Or a multiple of an equation together to make something cancel out. Okay? When you do elimination, you're only going to be able to cancel one variable at a time. You have to choose what variable you want to try to cancel, x or y. I suppose if you get really lucky and everything worked out in kind of a special case, both variables could cancel, but that's not common. So our goal is to get the coefficients of one variable to be opposites. So what do I mean? Well, if you had like a 3x in the top equation, I'd like a negative 3x in the bottom equation. I'm going to try to get them to cancel. If you don't have opposites in the problem I give you, then you have to make opposites. And you can make numbers opposite by multiplying an equation by a number. If you can't just multiply one equation by a number, then multiply both by a number. But don't forget to do it to all three terms. So let's look at this one. Technically it says solve, so you wouldn't have to do elimination. You could do substitution, but let's practice elimination. Most of them on the test, you have the freedom to pick whichever way you want to solve it. All right, so we've got 2x plus 3y equals 5, and negative 3x plus 5y equals 21. All right, we need to choose a letter that we want to try to make opposites. So what letter do we want to try to eliminate in this one? It doesn't matter, but we do need to make a choice. Yes?
X.
Okay, so we're going to try to eliminate x. I also don't want to multiply by fractions if I don't have to. So I'm going to choose to multiply both equations by a number. To figure out the number, look at what's in front of x now. You have a 2 and a 3. Think of a number that 2 and 3 both divide into evenly. What's a number that 2 and 3 both divide into? 6. So that's the goal. We need one of these equations to have a 6 in front of the x. We need the other one to have a negative 6. And because you picked 6, we shouldn't need to use any fractions. All right, let's start with the top equation. what could we multiply the top equation by so we get a 6 in front of the x? Yep, 3. And we're going to distribute that out. And what could we multiply the top equation by so that we have a negative 6 in front of x? I mean the bottom equation. Yeah, 2. So we're going to multiply by 2. William, if I multiply the top equation by 3, can you tell me what the new equation will be?
6x plus 9y equals 15.
6x, 9y, 15. Perfect. That's the same basic equation that we had originally. If you were to graph that, or graph the original on the calculator, they're the same thing. It's just a multiple of it. Because you could divide everything by 3, and then it would turn right back into what you started with. Reese, how about the bottom equation? If I multiply everything by 2, what will that be?
Negative 6x plus 10y equals 42.
10y equals 42. Right. Now you're going to add your equations together in columns. So make sure if they didn't do it, that you have like terms lined up. X is in a column, y is in a column, constants in a column. Sarah, what do I get when I add my first column up? 0. These are going to cancel. 6x plus negative 6x. And Kylie, how about my second column?
19y.
So 19y. Good. And my last column, don't forget that one on the other side, just the constants. Hadley, what did we get when we add those up? 57. Okay. And Eileen, what do I do now to get y by itself?
Divide by 19.
Divide by 19. Perfect. And what's that going to give me for y? 3. Yep. Most of the problems that you're going to see on the test, if not all of the problems on the test, the numbers are going to come out reasonably nice. So if you start getting answers like, 73 over 23, something that seems like it's not a nice answer, something's probably not right. So we got y equals 3. Aiden, what do I do now?
You just plug y equals 3 into one of the two starting equations.
Yep. Which one should we plug back into?
I went with the top one.
Okay.
Doesn't really matter though.
Doesn't matter, but the top one does have smaller numbers, so we can use that one. Unlike substitution, we don't already have one that says x equals. So we're going to have to get x by itself. Okay, so let's take what we got for y and plug that back in. So we get 2x plus 9 equals 5. Okay, bring the 9 over. And we get x equals negative 2. Okay, any question on that? So we kind of already alluded to this, but when you draw 2 lines, there's really 3 different things that can happen. This is one. These 2 lines, when you draw them, they cross in a single spot. What else can happen when you draw 2 lines? Besides crossing in a single spot. Yeah.
Could it never cross?
And what would that be?
Parallel?
Yep, you could draw 2 lines and they could be parallel, so they would never cross. So what do you think the solution would be then?
No solution.
That's a no solution. And there's one more thing that can happen. Yeah.
They're the same line.
They could be the same line, and what do you think the solution would be there? Infinite is the number of solutions, And then the solutions themselves are all real numbers. Yeah. So these are the three different scenarios that can happen when you draw two, or when you solve two linear equations. One solution, because they cross in one spot. No solution, because they're parallel. Or an infinite amount of solutions, because they are the same line. Okay, so we'll try a few, we'll try a couple special cases, and then I want to look at solving a 3-variable system. All right, so let's do this with elimination. And we've got to choose a letter to eliminate. Alex, what letter do you want to try to eliminate here?
X.
Okay, so we're going to eliminate the x. So which equation are you going to multiply? And what would you multiply it by?
The first one by 3.
Okay, so let's multiply the first equation by 3. Bottom equation, I would not change this time. You don't need to. Maggie, what do you get when you multiply the top equation by 3?
6x minus 9y equals 15.
Equals 15. Okay, bottom equation, we're just copying it over. Negative 6x plus 9y equals 10. Okay, Hunter, what happens when I add up my first column?
They cancel out.
They cancel out. And Reese, my second column? They cancel out. So William, what do I have left on the left side?
0.
0. And Aiden on the right side?
You would have
25. Okay, when all the letters cancel out, that's a special case. Okay, you're done. We just have to interpret what that means. 0 equals 25. Okay, what do you think about that? 0 equals 25. That's not true. So what do you think that means about the solution? That's a no solution. Yep. Okay, for the answer here, you wouldn't want to say the lines are parallel. Yes, that's true. You wouldn't want to say that's a false statement. That is correct, but the answer you would say, because the lines are parallel, because the statement is false, it means there is no solution. All right, so that's example 4. And let's look at example 5. All right. Sarah, what letter do you want to try to eliminate in this one? X, okay. What equation would you multiply, and what number would you multiply by to do that? Okay, so let's multiply the first equation by 2. Kylie, if I multiply the top by 2, what would be the new equation?
2x minus 6y equals -4.
Okay, so 2x minus 6y equals -4. Bottom equation, we're going to copy it over. Negative 2x plus 6y equals 4. Okay, we're going to add up all 3 columns and see what happens. So Hadley, what happens when you add up the first column?
0.
Get 0. Eileen, the second column? So that's 0, so we have nothing on that side. And then on the right side, William, -4 and 4.
It cancels out and it becomes 0.
And that becomes 0. Okay, all the letters canceled, so we're done. We get 0 equals 0. What do you think that means? Yep.
Infinite solution.
There's an infinite amount of solutions. Yep. Because if you were to draw those 2 lines by solving them for y, they are exactly the same equation. Okay, So any questions on two variable systems, either a regular or a special case, using elimination or substitution? All right. The last one we're going to look at is a three variable system. So I'll try to explain how we're going to do it, and then we'll do an example. Okay, so the first step is you're going to have three different equations to pick from. So there's lots of choices here. You're going to pick two of the three, and you're going to eliminate one variable. If you do that step correctly, you should end up with an equation that only has two variables in it when you're done. And then you're going to repeat that, but you're going to use two different equations. So now, pick two different equations, but you have to eliminate the same variable. You have to use the same variable you did the first time. So pick two different equations and eliminate the same variable. What that's going to do is it's going to give you another equation that has two letters in it. So this is going to give you a new equation with just two letters. This step is going to give you another equation that has just two letters. Now you're going to have two equations with two letters. That's the kind of problems we've been doing. And once it's down to two equations with two variables, you can solve that any way you want. Use substitution or elimination. I think elimination is probably going to be the better method most of the time. So now finish solving. When you solve, remember three variables, you got to write three answers. So x, y, and z. Okay. Or whatever letters they use, but x, y, and z are pretty common. Okay, so let's look at our problem. There's a good amount of copying when we do this, so you really want to be careful if you copy something, you copy it correct. Okay, so we've got 2x plus 3y minus z equals 1. I'm going to call that equation 1. So when I write down a number and I circle it, that means it's referring to an equation number. I'm going to call this equation 2. 3x minus 2y plus 2z equals 15. And the bottom equation, I'm going to call equation 3. X plus 4y minus 3z equals negative 8. Okay, so we need to pick two equations, and then we have to eliminate one of the variables in those two equations. What two equations do you think would be best to work with? And then what variable do you think we should try to eliminate? Yep.
1 and 3.
Yeah, 1 and 3 could be a good option. And what variable do you want to eliminate?
X.
Why x?
Because you have one of the x's and number 3 has a coefficient of 1.
Exactly. Okay, if you've got something with a coefficient of 1, that's going to make it easier to work with. So that's an equation you should probably pick to use, and that's the variable you should try to eliminate. So let's write down what we're going to do. We're going to eliminate here. We're going to eliminate x in equations 1 and 3. Okay, since I don't have enough space to do the work up there, I'm going to copy them down. 2x plus 3y minus z equals negative 1. 3x plus 4y minus 3z equals negative 8. Okay, so since you picked those two, can you tell us what you would have to multiply and what would you multiply by?
Multiply the bottom equation by -2.
Yep. Bottom by -2. Okay, that's going to keep the top the same. 2x, 3y minus z equals -1. And the bottom is going to become -2x minus 8y plus 6z equals 16. And now add them up. Reese, what do I get when I add all those columns up?
The x's are canceled.
Yep, x's are going to cancel.
-5y
Yep, -5y.
plus 5z
Equals 15. Now, normally I would say, okay, you're done with step 1. You have a new equation right here, and it only has 2 letters in it. But there's something you could do to this equation just to make it a little easier to work with in the future. Anybody see what we could do? Yeah, we can divide everything by 5. It's not necessary, but it will help. Right? So divide by 5. You get -y plus z equals 3. And that is my new equation, one of them. I'm going to call that equation 4. Okay, so there's our first step. Now, do that step again. We have to eliminate x, but you can't pick equations 1 and 3. You'll be doing the same thing over. We got to pick 2 new equations. So eliminate x. And which 2 equations do we want to use this time? It just can't be 1 and 3. Yep. Well, we'll come back to 4 in a minute. Let's stick with one of the original ones.
We can't use 1 and 3.
We can't use 1 and 3. Well, your options would be you could either pick 1 and 2, or you could pick 2 and 3.
I thought you meant you couldn't use either 1 or 3.
Oh no, you just can't use the pair of them together again.
Then 2 and 3.
Yeah, 2 and 3 would be a really good option to pick again because of this 1 right here. So you really want to keep using 3. But yeah, let's use 2 and 3. So 2 and 3. Okay, so let me copy them down. 3x minus 2y plus 2z equals 15. And 3 is x plus 4y minus 3z equals -8. Okay, so we are eliminating x. And what would you multiply x by, Maggie? Well, yeah, we gotta get it multiplied by -3 in the bottom, so it cancels out. Yep. So distribute out my -3. Top, keep it the same. 3x minus 2y plus 2z equals 15. And Elise, when I multiply that out in the bottom, can you tell me what I will get?
-3x minus 12y plus 9z plus equals 24.
Equals 24. Add up our columns. Alex, what do we get when we add them up?
-14y.
Okay, so negative 14y.
Is that 27?
2z.
Oh, 2z. Oh, 11d.
So 11z, yep,
39.
and
39.
equals 39. Okay, not much I can do with that one. There's nothing I can divide through by, so we're just going to leave it, and we're going to call that equation 5. All right, so now we have two new equations that we created, and each equation only has a y and a z. So the next step is to work with just equations 4 and 5. Okay, and we have to choose what letter we want to eliminate there. Okay, so now eliminate, and I'm going to let you choose whatever letter in equation 4 and 5. Okay, so what letter do we want to try to eliminate in equations 4 and 5? Oh, I haven't. Z, okay. Eliminate Z. So let me copy them down. So we've got equation 4 is negative y plus z equals 3. Equation 5, negative 14y plus 11z equals 39. And since we want to eliminate z, what would you multiply the top equation by?
-11.
Yeah, I'm going to multiply by negative 11. Okay, so let's do that. It's going to give us 11y minus 11z minus 33. And the bottom equation is getting copied over. Negative 14y plus 11z equals 39. And Maggie, when I add those up, 11y and negative 14y, negative 3y, z's are gone, and the other side, 6. Okay, so we have negative 3y equals 6. So Sarah, what does y equal? Sorry, say it again. Yep, negative 2. Okay, and now once you get your first answer, you're like 90% of the way done. Okay, we've done most of the work, we just have to start plugging back in. So the next letter I would solve for is z, and I would plug into equation 4. Negative y plus z equals 3. And plug that in right there. So negative 2. And that means z is 1. Okay, so now we've got z. And Hadley, what's the last letter I need to find? X, and we can do that by plugging back into any one of the 3 original equations. Doesn't matter. I would just pick the bottom one because it already has a coefficient of 1 on the x. So x plus 4y minus 3z. Okay, and now fill it all in. So x we don't know. Y we know is negative 2, so 4 times negative 2. Z we know is 1, so negative 3 times 1. So negative 8 minus 3 is going to give me negative 11. And William, what are we going to get for x?
3.
Yeah, 3. Perfect. And that's the steps of pretty much how it goes every time. So you eliminate to create a new equation, eliminate to create a new equation again, and then eliminate in the two equations you just made, and then you can get all your answers. But that's as organized and as compact as I can make it using elimination. Any questions on any of the steps? Okay. So we're not going to get into it, but a more efficient way to do this is with a matrix. And the reason it's more efficient is, one, you don't have to write down any letters the entire time you're solving the problem. If you look at all the work I have on the board, there's a lot of letters written in that work. I can eliminate writing all the letters and all the equal signs. So that saves some time. Also, it all eliminates choices. Okay? When we solved this, we had choices. We had to pick two equations, and then we had to pick a letter to eliminate. If you use a matrix, there's no choices involved. Right? Every single person, if you do it correctly, you would solve it exactly the same way and pretty much exactly the same steps. This, different people could do it all different ways. Right? So sometimes when you have more choices, it gets confusing because you don't know where to start. Right? But a matrix would eliminate that. Okay, so again, we're not going to do it. But just to show you how much writing it saves, if I was going to put all of that into a problem to get ready to solve with a matrix, all I would have to do is this. That's how I would represent all that information in a matrix. It's kind of like when we did cross product. We talked a little about the matrix. It's the same structure, but we're not doing cross product at all. But that's how it would look. So that's section 10. So that's our last section for this week. So homework tonight is 1 through 21 odd. Okay, what I'll do is we got about 15 minutes. I'll have plenty of time. I'll put all the test topics on the board. And if you have any questions or you don't know what I mean by one of them,